Hi everyone, welcome to the 2.5 through 2.7 notes. These are all about derivative rules. So the last couple of days we've been learning about the derivative and what it is, and to find derivatives we've been either finding the slope of the tangent line and estimating it, or we've been using the definition of the derivative. And today we're going to learn some shortcuts. And so as we've done the definition of the derivative, you may have noticed some patterns. And there were these two mathematicians who were alive like in the 1600s, Isaac Newton and Gottfried Leibniz, and they also noticed some patterns and they created these rules. And so our first rule is the derivative of a constant function. So remember, a constant is just any number without a variable. If f is the function with the constant value k, then the derivative, that's what d of dx means, the derivative of k is 0. And I wrote ak, the derivative of any constant is 0. So if I were to do over here the derivative of 3, that would be 0. The derivative of a million is 0. The derivative of 1/3 is 0. The other one is the power rule. And so this says if n is a positive integer and x does not equal 0, then the derivative, ignore this, that one, the derivative of x to the n power is n times x. So you basically take this n value and you move it in front of x, and then you take the n value that's left as the exponent and then you subtract it by 1. So the derivative of x to the n power equals n times x to the n minus 1 power. So for example, the derivative of x to the 5th power is 5x and then 5 minus 1, which is 5x to the 4th power. And you can probably do these in your head. You just take 1 away from the exponent and then you move the exponent out front. Let's say that this function has a constant in front of our variable. So if u is a differentiable function of x and x is a constant, then the derivative of kx to the n power is k times n times x to the n minus 1 power. So again, for example, let's say we were taking the derivative of 2x to the 5th power. That derivative would be 2 times 5 times x, 5 minus 1, which equals 10x to the 4th power. So those are our three main derivative rules. Other things we'll see as we go on is that the derivative of two separate terms can be added together to find the derivative as the whole. The difference of two terms, if you find the derivative of those as parts, you can put them together, and we'll learn that in a little bit. But one thing to note is that so far there is a little bit more to finding the derivative of a quotient, and there's a little bit more to finding the derivative of a product, and we'll learn that later next week. The product and quotient rule are things, and so you can't find the derivative of like e to the x times x squared the way that we know how to find derivatives yet, but we'll get more to that next week. So for the following problems, find dy dx. Remember, dy dx, what that is asking you to find is the derivative of y with respect to x. So that just means the dependent variable is y and the independent variable is x with respect to x. So the derivative of y equals 100, well, that's just a constant, so the derivative of that is 0. So for this next one, dy dx, so we're trying to find the derivative of 2e. Well, e is a constant. It's equivalent to around 2. And so that's just like basically 2 times 2. And so that would be like around 4. So the derivative of 4 is just 0. So that's the same thing like if you had 2 pi. That's just a constant. So it'd still be 0. This next one, notice that we have some like terms. So I'm going to go ahead and simplify this equation real quick. 6x plus x is 7x. So if you're to find the derivative of this, we're going to use the power rule. And you're not going to have to use the power rule after you see this. Know that basically the exponent on this x is 1. So if you were to pull that down, you would have 7 times 1. And then you do x to the 1 minus 1 power. And that would simplify to 7x to the 0 power. And anything to the 0 power is 1. So that'd be like 7 times 1, which equals 7. So you're not going to have to do that every single time. But if you ever have something like 3x, the derivative is 3. 10x, the derivative is 10. Negative 20, negative 20x, the derivative is negative 20. But that's like how the power rule shows you that that's the answer. This next one, so I'll take the derivative of these two terms separately, and then I'll subtract them. So the derivative of 12x to the 4th power is going to be 12 times 4, and then you would do 4 minus 1, and you get 3, minus 2x And then I would do 2 minus 1, and then I just get 1. And that simplifies to 48x cubed minus 2x. This next one's just one term. There's a 4/3 and a pi, but those are all just coefficients. So we don't really have to like do anything about them. So we'll have the derivative of that is 4/3 pi times 3. And then again, I'll take the exponent 3 down by 1. So my final answer will be, well, if you look, this over here is, hold on, where am I looking for this guy? Right here, this is division by 3. This is multiplication by 3. So these cancel out. So I'll be left with 4 pi x squared because 3 minus 1 is 2. So those are the derivatives of those first sets of problems. These next set of problems are a little bit more challenging because they involve exponents that are fractions or exponents that are negative. So if you're struggling with these next ones, my advice to you is to freshen up on your exponent rules. But the calculus behind it is the same. So again, I'm just like starting to use different notation, but f prime, that notation means find the derivative of f. So f prime of x, if the original function is f of x, same thing I will do as I did last time. I'm going to pull 2/3 down out in front, so I'll get 2/3 x, and then I'll do 2/3 minus 1. Now I not only have to use exponents here, but I also have to remember how to subtract fractions. And so remember that if you want to subtract fractions, you have to have like denominators, the same denominators. So I'm going to take 1 and I'm going to change it into 3/3 because 3 divided by 3 is 1. And now they have common denominators. This is going to equal 2/3 x to the negative 1/3 power. And you technically could keep your answer just like that. You would get full credit on the AP test, but like if you're working on a multiple choice question and you don't see this answer, then you need to convert it. And so this is a review of exponent rules. If you want to make an exponent positive and it's negative, you flip its position in the fraction. So if it's on the numerator and it's negative, you want to make it positive, you move it to the denominator. If it's on the denominator and it's negative and you want to move it to the top, you put it on the top. So this would be 2/3 x to the 1/3 power. And because it started out as an exponent, I'm going to leave it as an exponent. I'm not going to put it in radical form. This next one, so this is something interesting about this. You might be like, how the heck am I going to do this one? But this is essentially just the power rule tool too, because you could write the square root of x in terms of exponents. And so the way that this works is that if you think of an exponent or a radical over here, this is a square root. So technically, sometimes like if you see like cubed roots, you would see a 3 out in front. But because it's a square root, you don't always write it, but it is a square root. So that's a square root. And then the exponent inside the radical is just 1. And so when you move something from radical form to exponent form, all you do is you take the exponent on the inside and you put it on the top. And then you put the exponent on the outside and you take it to the bottom. And so now you're finding the derivative of f of x equals x to the 1/2 power. And because that is in exponent form, you can go ahead and you can find the derivative of that using the power rule. So anytime you see a radical, the way that you find the derivative of a radical is you switch it to exponent form. So I'm going to write this down, radical, switch to exponent form, exponential form. So that's how you do those ones. And so then I would just proceed and find the derivative. So f prime of x, one place that is really easy to mess up too for students is they'll switch it from radical form to exponential form and they'll be like, oh, I found the derivative, but you didn't find the derivative. You just found the original function in a different form. So don't do that. So now I'm going to take this 1/2 and I'm going to move it out in front. So it'll be 1/2 x, and then I'm going to subtract 1/2 by 1. I just know that 1/2 minus 1 is negative 1/2. So that right here, I've taken the derivative. I'm done once I get there, but I am going to go ahead and simplify it just so we can get more practice simplifying these. That's going to become 1/2 and then x to the 1/2 power. I'm moving it to the denominator to make it positive. And then because it started in radical form, I'm going to make my answer end in radical form. So I'm going to take this back. I know that x to the 1/2 power is equivalent to the square root of x. So that's the answer there. So this part over here is the calculus. Well, I guess this part right here is the calculus. This part right here is exponent rules and radical rules. And so if this is the part that you're getting stuck on, go to iExcel, go find Khan Academy, look up exponent rules and converting from exponential to radical form, and try to freshen up on those skills. Because if that's what's holding you back and not the calculus, I don't want algebra things to hold you back. This one says example 3, find f prime of x. So same thing. My exponents are getting cut off here, but this one is a radical. The way that I find the derivative of radical is I convert it to exponent form. So remember what I said, the exponent inside the radical becomes the numerator and the exponent outside the radical becomes the denominator. So I have converted it into exponential form, and so now I can find the derivative. So I have f prime of x equals, I'll take 3/4 and put it out in front of x, and I'll do 3/4 minus 1. You might know what the answer is off the top of your head, but if not, 1 is equivalent to 4/4. So I'll get 3/4 x to the negative 1/4 power. I have done all the calculus. Technically, I applied the power rule here. So technically this is the derivative. It's just not simplified at all. And so I'm going to go ahead. This could be our final answer, but I'm going to go ahead and simplify it. So I'm going to make it 3/4 x to the 1/4 power. And then again, because it started out in radical form, I'm going to let it end in radical form. And so when I go backwards, the denominator goes outside, the numerator goes inside. So this will be the 4th root of x. And then I could put a 1 here if I wanted to. You don't have to, because you don't have to write x to the 1 power. Okay, this next one's just a negative. So if I want to find the derivative, I do pull -3 out in front. So -3. Then I do x to the negative 3 power minus 1. Just look out for your exponents. The answer is not going to be -2 here because you have a negative number and you're taking away 1. It's going to be -4. And then because it started out in that form, I'm just going to leave it like that. I'm just going to leave it however it started. Technically, that's like not the most simplified because it's more simplified when all the exponents are positive, but that's okay. This one, you also might think that you can't do this with what we know so far, but you actually can, because if you think about this denominator right here, the denominator has an exponent. It's x to the 1 power. And if you ever want to flip the sign of an exponent, all you have to do is move its place in the fraction. So I'm just going to take this and I'm going to move x to the top, so it'll become like 1 times x to the negative 1 power, which is just x to the negative 1 power. And so I have not found the derivative yet. Haven't done anything like that. Done no calculus, just done algebra. But now in a form, it's set up so I can use the power rule. If you don't want to use this, you can just use the definition of the derivative, but you shouldn't do that. So the derivative of this is I pull the -1 out in front, and then I do x times x to the negative 1 power minus 1. I'll get -1 x to the negative 2 power, and then I'll simplify it. So I'll make it -1 over x squared. That is my answer. We're going to go on to some, not necessarily more complicated problems, but some problems that have more than one term in the equation. So for example, this one has more than one term in the equation. It says find dp dt, which means find the derivative of p with respect to t. And so I'm basically just going to find, we have 4 terms here, t cubed, 6t squared, -5/3 t, and 16. And I'm just going to kind of go down the row, find the derivative separately, and then combine them. So dp dt, I'll just do one at a time, and then we'll simplify. We'll do the derivative of t cubed. And that is just 3t squared. And you're going to start being able to do those things in your head. I just moved 3 out in front, and then I took the exponent 3 and I've subtracted it by 1. Same thing with the next one. It's going to be 12t. 6 times 2 is 12. 2 minus 1 is 1, so I don't even need to write that. The derivative of -5/3 is just -5/3, because there's technically like a 1 here. 1 minus 1 is 0. That makes the variable go away. And then the derivative of a constant is 0. And so I didn't even need to write that. But your final answer here is this. Not too bad. Okay, this next one's a little trickier because if you notice, it's not really set up to use the power rule. How I know that is, 1, I have variables on the denominator, so that means it's not set up, and I have a radical. And this is technically not set up, but like it looks a little icky. So I'm going to rewrite my equation. I'm not finding the derivative, I'm just rewriting it. So this is equivalent to, if I want to move t cubed to the top, I'm going to make it t to the negative 3 power. Then if I want to put the square root of t in radical form, that, if we did this above, is just equivalent to t to the 1/2 power. And then I'm just going to write this, and let's just keep it how it is. It doesn't really matter. But if you want to write it as like 1/4 times t to the 6th power, you can. But that's the same as this. So I have found an equivalent form of p that will allow me to use the power rule, but I actually haven't found any derivatives. Now I will do that. So now, the derivative of t to the negative 3 power is negative 3 t to the negative 4 power. The derivative of negative 3 t to the 1/2 power is negative 3 times 1/2 t, and then 1/2 minus 1 is negative 1/2. And then the last part, t to the 6th power divided by 6 is plus 6 times t to the 5th power all over 4. So that's my answer. That's the derivative. Like, and on the AP test, if it's a short FRQ, like, you don't have to go any further. You could stop there. But it's nice to know how to simplify it, especially for MCQ questions. So if I were to simplify this, I'm going to make it negative 3 over t to the 4th power. This will be negative 3/2. And then t to the negative 1/2 power would be t to the positive 1/2 power on the bottom, and that's just equivalent to radical t. And then I technically 6/4 is equivalent to 3/2. So if your problem is from here to here, again, that's just your simplification algebra. But if you got the first row, that means you know how to do the calculus, and that's our number one goal for today. Okay, we'll do a couple more. So this one says differentiate the following functions. Differentiate means take the derivative. So many different ways that you can say this. Take derivative. And it says, with respect to x, where a, b, and c are constants. So that just means they're like, it's like 7 times 4, right? So the derivative of 7c, right, dy dx, that's just 0. Because that would be like, if c was 2, it would be 14. The derivative of 14 is 0. For this next one, it would be dy dx. So the square root of 3 is just a constant. So, like, again, the derivative of 3x is 3. So the derivative of square root of 3x is square root of 3. This next one, you would do a times 4. We don't know what a is, so it doesn't get to go away here. Times x, 4 minus 1 is 3. And then the derivative of, again, like 2x would be 2. So the derivative of abx would be a. And ab, sorry. And if I simplify that, I get the square root of 3 plus 4ax cubed plus ab. And you could have like one problem on your homework about that. Okay, so that's the power rule, the constant rules. Now we're going to move on to 4 different rules. I think we're going to go over, probably for the sake of time, we're going to skip one of these. But we're going to start by going over how, so the other ones people probably picked up by patterns. This is how mathematicians figured out what the derivatives of these popular functions are. So this is how they figured out the derivative of cosine, sine, e to the x, and the natural log of x. That's what ln of x is. So we're going to explore that graphically. We're going to skip example 2, but we're going to look at example 1. And so basically, if you remember, the derivative is the slope of the tangent line. So they were looking at cosine x, and they were trying to figure out what is the derivative of cosine of x. And so what they did is they decided to make a chart. And so they picked a bunch of x values, and then they tried to figure out what is the derivative. Y prime just means the derivative. And again, the derivative is the slope of the tangent. So the most popular points that we think about when we do cosine are the ones on the unit circle. So I'm just going to go left to right and remind you. So negative 2 pi, we're going to look at. Negative 3 pi over 2 is another value on the unit circle. Negative pi, 0, 1. This is probably, oh, sorry, I skipped pi over 2. Pi over 2 was this value right there. Negative pi over 2, 0. This value is pi over 2. Pi, this value is 3 pi over 2. And some of these are going to repeat, so we're not going to do all of these every time. But what they did is they went and they found the derivative at all these like really popular places on the function. So let's start with negative 2 pi. So negative 2 pi is here at the top of the curve, and the derivative of this, well, this is the tangent. The slope of that tangent is 0. So the derivative of at negative 2 pi is 0. The derivative at negative 3 pi over 2, this is going to be harder to graph. I know that it didn't, but I'm just going to trace the curve of the graph. And it basically, if you notice, just looks like negative 1. This one right here is again 0. So I'm just going to go ahead and throw anywhere where we were at like the top of the curve, like at 0, it's at 0, at pi, it's at 0, and 2 pi, it's at 0, because all of those places we are at the top of the curve, so the tangent line is going to be there. For this next one, at negative pi over 2, well, that's just positive 1 this time. At pi over 2, again, it's just negative 1, because this curve just repeats itself, so these are just going to repeat itself, and then you can probably guess this one is going to be positive 1 right here. And so if I go over here now, and I take my points, and let's say I sketch them, and we're going to see what we find. So I'm just going to plot the big ones. Negative 2 pi, negative pi, pi, 2 pi, and then for my y-axes, they don't ever go above 1. So I'm just going to put 1, negative 1. And I'm going to start graphing these points. So negative 2 pi 0 is here. Negative 3 pi over negative 2 is here. Just graphing the points I see on the table. And now I will connect them. Okay, sorry, that looks kind of ugly because it got a little, oh, sorry. I messed it up. 3 pi over 2 would have been right here, and then 2 pi goes here. So let me do that again. So it should look like this. And I know that you might not have the greatest knowledge of trig, but what this function right here is, it is the sine curve flipped. So this is actually y equals negative sine of x. And so that's how mathematicians figured out what the derivative of cosine is they just found the derivative at a bunch of different points. They found the slope of the tangent at a bunch of different points, and then they made some educated, not guesses, but they figured out that that mimicked the sine curve, the negative sine curve perfectly. And so that's what we're going to do with this, but I want to skip for the sake of time. But we could do the same thing with the sine curve. So like the derivative of sine is, this is what the derivative of the sine curve looks like. And we just figured that out by doing a bunch of slopes of tangent lines, and the same with the natural log of x. That's the derivative of the natural log of x. And so you need to know these. And now that you know how people figured them out, you can just memorize them. So the derivative of sine of x is cosine of x. The derivative of cosine of x, as we just learned, is negative sine of x. This one's the easiest one in all of calculus. The derivative of the e to the x is just e to the x. And then the derivative of the natural log is 1 over x. And so maybe it would be helpful for you to pull out the flashcards so that you can learn more about these. But we're going to do just a couple practice problems. It won't be very hard with these, and then we will be done with these notes. So you're probably just going to have to hold on to these notes for a while and go back and reference them. But the derivative of f prime of x, well, 12 is just a constant, so it gets to hang out. And then the natural log of x, that derivative, as we just learned, is 1 over x. So if I simplify this, this is 12 over x. So the derivative of 12, natural log of x, is 12 divided by x. We just learned that the derivative of sine of x is cosine of x. And then this is just the power rule here. So 4 times 7, 28. X to the 7th power, take away 1, x to the 6th power. So that's our answer for f prime of x. You can go through this slower if you want to. This next one, dy dr, is asking for the derivative with respect to r. So 7 times e to the r, well, e to the r, the derivative of that is just e to the r. The derivative of sine of r is cosine of r. And then the derivative of 19r is 19. So I just want to make sure I got all my answers correct. Good. Okay, last one. Again, the derivative of the natural log of r, just a different variable, but it's just 1 over r. And then the derivative of cosine is negative sine of r, so we're going to have to simplify that. And then the derivative of 2 is 0. So the derivative with respect to r is 1 over r minus 10 sine of r. And those are the notes for the day. So make some flashcards, do some practice problems from the homework. Good luck. Thanks for watching.